The universe, for all we have learned about it, we have still only scratched the surface. Everything that we can see around us makes up less than 5% of what's actually out there. All the rest is called dark matter and dark energy. What are they? We still don't know, even though they determine the fate of the universe. We have confirmed over 3,000 planets orbiting stars other than the Sun, but most of these extrasolar planets are huge and very close to their host star. How common are planetary arrangements like our own? And how many planets in our galaxy have the potential to harbor life? These fundamental questions are part of what drives NASA science, and they spur the development of new space observatories. WFIRST, the Wide Field Infrared Survey Telescope, is one of these. WFIRST is built on an existing telescope that is very similar to Hubble, but with the added benefit of 25 years of technological development. Each of the wide field instrument's images will have the depth and clarity of Hubble, but cover a sky area 100 times larger. That's thanks to an arrangement of 18 sensors in the camera to Hubble's 1. Viewing the sky in infrared wavelengths allows astronomers to see relatively cool objects like interstellar gas, dust, and exoplanets, as well as stars. WFIRST will lead the push to understand dark energy, a mysterious pressure that is making the universe expand ever faster. Dark energy makes up 68% of the cosmos, and its properties, whatever they are, determine the fate of the universe. But no one knows what it is or exactly how it behaves. Another mysterious component of the universe WFIRST will study is dark matter. Dark matter accounts for 27% of the cosmos, 5 times as much as the matter we can see, but has remained invisible to us. We can detect it by seeing how its gravity warps light from distant galaxies, a process called gravitational lensing. WFIRST's powerful 2.4-meter telescope will also help us in the search for extrasolar planets, or exoplanets. Using the same gravitational lensing principles, WFIRST will watch for so-called gravitational microlensing events, a unique light signature caused when a planet and its host star pass in front of a background star. This technique extends planet detection capabilities to smaller and more distant worlds than other methods, so it can catch ones that have eluded us before. WFIRST's enormous field of view will allow scientists to watch huge portions of the Milky Way for these microlensing events. As a result, they will be able to complete the census of exoplanets begun by Kepler. To deepen its study of exoplanets, WFIRST will also be outfitted with a beyond state-of-the-art coronagraph. The coronagraph works by masking starlight to reveal the faint light reflected by any potential planets. WFIRST coronagraph will directly image and analyze Neptune-sized planets in orbits slightly greater than Earth's. Existing coronagraphs can only image larger planets that are much more distant from their host stars, so this new capability represents a dramatic improvement. In order to make all these measurements, WFIRST will move to nearly 1 million miles from Earth and orbit a special area of space called a Lagrange point. This particular point, called Earth-Sun L2, is one of several locations where the combined gravitational effects of the Sun and Earth create a zone of stability where a spacecraft can pace Earth as it orbits. WFIRST will be a way to answer many of the biggest questions about the universe. Questions like, how does the universe work? And, are we alone? Its wide field view and coronagraph will complement missions like the JAMES Webb Space Telescope and the Transiting Exoplanet Survey Satellite, TESS. WFIRST will be an indispensable part of space science during the next decade and beyond.